Hi everyone. In this video, we are going to talk about how to write the equation of parallel and perpendicular lines. And this is a little different than what we've already been working on. We have been focusing on the slope of parallel and perpendicular lines, which I'm going to review right here in the first box, but we are then going to take it a step further. So let's look at the review points here. We know that parallel lines have equal slopes. That is what keeps them from bumping into each other when we use the rise over run. We also know that perpendicular lines have opposite and reciprocal slopes. So I just jotted down a quick example. Let's say the slope of one line is rise 2, run 3. Well, then its perpendicular slope on the second line would be flip the fraction, so it's 3 over 2, and change the sign from positive to negative. So opposite signs and reciprocals. So we're really good at this now, and we're ready to add on to it. So here's what we're going to be working on. We're going to be given one linear equation and a random point. You're going to be asked to create another equation that passes through that point, and it must come out parallel or perpendicular to the original line. So you'll be working with two lines at the same time. So let's look at our first parallel line example. It says, write the equation of a line that passes through this point and is parallel to this line. So I thought first things first is we would look at this visually on a graph. So what I've done is I've already graphed the line y equals negative 4x plus 1. I did that in blue. And I've plotted the point negative 2, positive 7 in orange. Now I am asked to build a parallel line. So what I need to know is that parallel lines have equal slopes. So I'm going to use a slope that's the same as this graph's slope. So the slope of the line that they gave to me is negative 4. So I'm going to graph a second line with the slope of negative 4. But it has to go through this point. So I'm going to start right here at the point negative 2, 7. So from negative 2, 7, I'm going to go down 4 to the right 1. Down 4 to the right 1. I'm just going to keep on following that pattern to fill up my graph. Down 4 to the right 1, down 4 to the right 1. And you will see when I connect all these dots, these lines are very, very, very close together, but they never touch each other. They are parallel, and I've gone right through the point that's designated. So the challenge is, can I write the equation of that line? Well, when I know how to write equations of lines, it's easy. Y equals mx plus b is the equation of a line. The b is the y-intercept. This line is cutting through the y-axis at negative 1. And I know that my slope is going to be down 4 over 1, down 4 over 1, or negative 4. So that will go in the m position. So the equation of my line is y equals negative 4x minus 1. Now the blue line and the orange line are parallel to each other. One has a y-intercept of positive 1 and one has a y-intercept of negative 1. So you could graph all of these problems out and read the graph to build the equation of the line. Of course, the trouble with this comes when we have y-intercepts that are really, really large or points that are really, really large. We might need an algebraic approach. So that's what I'm going to show you on your notes is an algebraic approach. And it's going to feel really similar to what we've already been working on. We know that in the equation y equals mx plus b, the x and y represent points. So I'm going to use negative 2 and 7 as the x and the y. We also know that the word parallel means we have to have two lines with the same slopes. So the slope of this line is negative 4, which means my parallel slope is also going to be -4. So I'm going to put in a -2 for the x, a +7 for the y, and a parallel, that's what this symbol means right here, parallel, a parallel slope of -4. Let's fill in y equals mx plus b. 7 equals -4 times -2, and I will be solving for b. Now that looks really similar to work we've already done in this unit. We're plugging in an x and a y for the point, and we're plugging in a slope value. Now we solve. -4 times -2 is 8. To get b all by itself, I need to subtract 8 from both sides. 7 take away 8 is -1, and that's equal to my b value. Okay, here's the two important parts. We've got a parallel slope that's -4. We just solved for a new y-intercept of -1. So when we put all this together, the new equation of our line is y equals -4x minus 1. -4 is in the m position. -1 is in the b position. Let's just bring back the graph to confirm what we're seeing here. On the left, I graphed in order to just show you a visual of what's going on, and we got the equation y equals -4x minus 1. And on the right, we worked this algebraically, and we still got y equals -4x minus 1. So now you really have two methods to work these problems. All right, let's try example 2, and we're only going to work this one algebraically. It says, write the equation of the line that passes through the point 3, -1. That's your x and y. And it must be parallel to this line. Now, the problem with this line is it is not in slope-intercept form. So the first thing I need to do is change this from standard form into slope-intercept form. First, I'll subtract x from both sides. That leaves me 3 times y equals, now I want to build this into y equals mx plus b pattern, so I'm going to write -x first plus 9 second. If you want to put a -1 as the coefficient in front of x, feel free to. Now I need to get rid of this -3 that's attached to the y value. That's a multiplier, so I'm going to divide by -3. Y equals -1 divided by -3 is going to reduce to 1/3, positive 1/3, x. And then 9 divided by -3 is -3. So the equation of this line is y equals 1/3 x plus 3, where 1/3 is the slope. So a parallel slope has to be exactly the same, which means the parallel slope is also going to equal 1/3. Now I have all the parts to plug into the equation. Y equals mx plus b. I'll put a -1 in for y, that came from the point. I'll put a positive 1/3 in for x, that came from solving for y and finding the slope. I'll put a positive 3 in for x from the point, and I don't have a value to plug in for b, so we'll find our own value. 1/3 times 3, 1/3 of 3 is 1. To get b by itself, I'll subtract 1 on both sides. So I have -2 is equal to b. Time to put it all together. I've got my parallel slope here. And now I have my new y-intercept of the second line that I'm trying to build here. So when I put everything together, I will get y equals positive 1/3 x minus 2 as my final equation. If you took the time to graph these two lines, They would wind up parallel to each other. Whew, okay, that was a lot about parallel. Now let's talk about perpendicular. The process is really similar, except the adjective has changed. We're not trying to build a parallel set of lines anymore. Now we're trying to build a perpendicular set of lines. Let's read the question. Write the equation of the line that passes through the point 4, 3 and is perpendicular to the line y equals 2x minus 4. I know I'm going to use 4 and 3 as my x and y. In this equation, the slope is 2, but I'm trying to build a perpendicular line, so I need to know what to do with perpendicular slope. Let me remind you. Perpendicular lines have opposite and reciprocal slopes, so I need to change the sign and flip into the fraction. I'll go from a positive 2 to a negative 1/2. So I'll be plugging these things in. Now I'm going to pause real quick, put a pause on that. I want to show you what that will look like graphically before we solve it. So again, I've graphed the line 2x minus 4 in blue, and I've plotted the point 4, 3 in orange. I need to use a negative 1/2 as my slope, which means from this point, I'll go down 1, right 2, down 1, right 2, down 1, right 2. To go the opposite way, I would go up 1, backwards 2, up 1, backwards 2, up 1, backwards 2. And there's my y-intercept. Let's count it out. That's the point 1, 2, 3, 4, 5. So if I were to write an equation that represents this orange line, it would be y equals the negative 1/2 that we talked about for slope plus 5 for the new y-intercept. Notice these two lines hit perfectly at a right angle. That's the definition of perpendicular lines. Okay, so now let's see how we're going to get this plus 5 algebraically. I need to write the equation of the line in slope-intercept form. I'm going to use 4 in the x spot, 3 in the y spot, and negative 1/2 in the m spot. So 3 is equal to negative 1/2 times 4, and I will solve for b. Half of 4 is 2, and this is a negative value. To solve for b here, I'll have to add 2 to both sides. And there it's happening. I think you'll see it. 3 plus 2 is 5, which is now my b value. Remember, that b represents the y-intercept, so let's confirm that on our graph over here. Remember, the y-intercept is where it crosses the y-axis, and my orange line crosses through the y-axis at positive 5. Final equation of the line, y equals a negative 1/2 to represent the perpendicular slope times x plus 5 as the y-intercept for this line. You guys, if that's enough for you right now, you can stop the video and get to practicing. I am going to do one more example of perpendicular, so I'll do number 4 here. If you want to continue watching, thank you. And if you need more practice problems, check out the back here. It's full of practice problems. Okay, so let's check out number 4. Write the equation of the line that passes through the point negative 5, 1 and is perpendicular to the line 5x plus 3y equals negative 21. Negative 5, 1 is the x and the y. What I don't have here is the slope. So I have to do a side problem first. I have to turn this standard form into slope-intercept form, which means I have to solve for y. The first step I'm going to do is subtract 5x on both sides. And now I'm going to be really smart about how I write it so it starts to look like y equals mx plus b. I'm going to write negative 5x first and negative 21 second. Now I need to get rid of the 3 that's in front of the y. It's being multiplied right now, so I'll divide to get rid of it. So y will be equal to negative 5 over 3 can just be written as a fraction, but it can't be reduced. Negative 21 over 3 can be reduced to negative 7. So the slope of this line is now negative 5 over 3. It's really easy to see now because it's in the m position. So to build the perpendicular slope, I need to flip the fraction and change it from a negative into a positive. So here's what I'm going to plug in for my new equation. I'll have negative 5 for the x, positive 1 for the y, and positive 3/5 for the m. 1 for the y, positive 3 over 5 for slope, negative 5 for x, solving for b. Don't get stressed out about this. Use a calculator or recognize that the 5 on the bottom and the large 5, whole number 5, will cancel out. 3/5 of negative 5 is negative 3. Solve for b by adding 3 to both sides. And I'm going to get 4 is equal to b. Now to write my whole equation, I need to use the perpendicular slope and the y-intercept we just solved for, which is a positive 4. If you were to graph our final answer compared to the original problem, they would hit at an exact 90-degree angle. Okay, guys, I know this was one of the longer videos in our series. I was trying to make sure that you saw a graphical approach as well as an algebraic approach because I think some of you will relate to the graphing more than the algebra. So keep practicing. There's plenty of practice problems on the back. Happy studying.